Yes, we see it. Thank you.
Okay. All right. So apologize, I didn't switch into the share mode. So as I was indicating, I'm going to provide an update of the projects going on in the SDN NFV work area. And the name of the group is because we apply the SDN software-defined network and network function virtualization techniques to the broadband network. This slide is provides a little context showing the broadband form reference architecture, and the parts that are included inside the red dashed lines are the parts that the SDN and the V work area are addressing. There are four main projects in SDN and the V area. Cloud CO defines a new architecture and related interfaces for central office hosting infrastructure that utilizes SDN and NFV cloud technologies to support network functions. We have a project on fixed access network, which defines the technical specs associated with access network sharing, including both access and aggregation nodes. Slicing is used to logically partition and isolate the network resources among the various virtual network operators that share the same infrastructure. Next, we have the automated intelligent management. The automated intelligent management project specifies the architecture and interfaces for implementing a logical pipeline framework for implementing machine learning and artificial intelligence algorithms to automate some of the management functions and realize rapid troubleshooting and preemptive maintenance. Finally, we have the Metro Computing Networking project, where we're defining a architecture with in-depth integration of computing and network on top of the cloud-based operation networks, or cloud-based broadband networks, with the purpose of interconnecting isolated edge sites as one cloud to provide edge computing services and load balancing among the edge sites of the network. Now, if you're new to the broadband forum, this slide's probably a key takeaway because it shows not only the projects, but also if you're recently involved with the SDN NFV work area, some are sometimes confused because we have more than a dozen specifications being developed in parallel. So that could cause some confusion about which ones you want to really pay attention to. Now, each of these I'm going to have additional details on, starting off with the cloud-based central office project, which is our best known project. It represents a transformation of the traditional big iron or monolithic central office. By applying SDN and NFV techniques, it allows the data plane and control planes to be separated. The elements that make up a central office can then be separated and distributed over a large geographic area, thereby redefining what makes up a central office. And the name, by the way, was a very contender name. But the central office transformation occurs because functions that were previously locked into purpose-built boxes are now being defined and virtualized in the cloud. Using software-defined networking for management and control, the network functions associated with a network node or an element of the user plane, control plane, and management plane interfaces. Protocols are specified, data models are developed and abstracted and automated. So some of the key specs that have been part of this project, we have the basic architectural framework document, which we're now working on a new issue of. We define the use cases. We defined application notes and testing, which is in TR 413, which is towards the bottom of the slide. We've also developed migration and coexistence, and you heard this, I think, in the first morning sessions as well. This is important to operators, and I'll have a few more words to say about that. And as a result of developing migration and coexistence in TR 408, that sort of led to this long list of interface specifications. You know, combination of the architecture framework and the migration coexistence led us to undertake the development of these various interface specifications. So I'm not going to go through each of them in detail, but some of them are published already as TRs, others are still in development, but are approaching close to being published. The migration coexistence also relates to the open broadband access abstraction, or the BAA. And we'll talk a little bit more about that. So OBBAA is an open source reference implementation of the Cloud CO access network abstraction layer. And earlier this morning, before we, in the first half, Lincoln talked a little bit about this. So I'm just going to be very, very brief. It was clear again, as we're developing TR 408 for migration and coexistence, that most service provider networks need to interconnect existing access network parts, such as DSLAMs, ONUs, OLTs, to a Cloud CO architecture, while also allowing new access node architectures, including white boxes, to be implemented and used in the network as long as they comply with the Cloud CO principles, where we have data plane, control plane, and management plane separation. The broadband access abstraction, or BAA, is an adaptation layer which is being implemented as open source code and based on the Cloud CO specifications. Because because BAA is open source, it operates actually as a separate work area from the SDN NFV, but we work in close collaboration. And because it's also open source code, there are different IPR rules that apply. On the right-hand side, the current active contributors to the BAA team are shown on the right. And by being active members, they commit resources, staffing resources, to help progress this effort. The OBBAA activities have been going on for maybe getting close to 3 years now, as Lincoln talked about and showed in one of his roadmap slides. We are now working on release 4.0, and releases are issued roughly about every 6 months. And the current work is going on working and expanding the feature set that's included in the BAA, as well as the demo, which Lincoln talked about for high-speed internet service with disaggregated access node, orchestrated edges, and client service steering. So this is part of the OBBAA activity. Protocol chart. We have the BAA layer in the middle. The lower layer represents access node, and the top layer is connected to the Cloud CO management and control elements. And so the BAA adaptation layer is in the middle, allows an existing access node to be connected to a Cloud CO infrastructure. And the disaggregated OLT solution can be built, which is built on the Cloud CO principles, can connect to the Cloud CO over a simplified BAA layer. So you don't have to implement necessarily all of those elements that are shown in the BAA layer. Depends if you're trying to connect into connecting an existing access node into the Cloud CO infrastructure, or if you have a new disaggregated access node, such as an OLT, that would have a simplified version. Fixed access network sharing identifies a new type of virtual network operator, or VNO. It specifies the requirements associated with both the VNO and the infrastructure network provider sharing their infrastructure. This results in new service offering for the infrastructure network provider. It reduces the cost for small and virtual network operators. FANS specifies the architectural model, defines the topologies, deployment scenarios, and specific virtualization requirements needed to successfully deploy a shared access network building on SDN. TR 386 defines the interface requirements of the equipment for the infrastructure provider and for the virtual network operator. Automated intelligent management. As the scale of the network increases, OpEx increases with it. The AIM project is defining mechanisms in order to reduce the OpEx. So the project specifies the logical framework of access and home network operations and maintenance automation. The framework identifies the necessary functional blocks, logical connection descriptions, and information flows between the modules. WT 486 is defining the interfaces for machine learning and interconnecting to existing operation support systems. Our newest work area, the Metro Computing Networking, is for Carrier Edge Cloud. It is considered a major growth point for cloud computing innovation. It builds on cloud CEO principles. Metro Computing Network represents new business opportunities for the telco ICT transformation. With WT 466 as a framework spec, it identifies essential functions at the edge of a cloud CEO and the role of automation. With the maturing cloud CEO, which supports local data centers, placing data and compute resources closer to the user, it enables a new set of carrier services. We are also starting work on an interface architecture and interface spec that will define new kinds of requirements or in the new interfaces that are not already defined to support the Metro Computing Edge, such as for connections into the automated intelligent management systems. Just wrapping up, this highlights some of the benefits, and then these are benefits not only for participation in SDN and NFV work areas, but also basically the entire broadband forum. So I'm not going to go over those anymore, but I just urge you that please join the broadband forum and participate in shaping the future. And this slide was not updated. I had originally a link that people could click on or take you to the main broadband forum website if you want to get more details about joining. And that is it.